So hey everyone, I am so excited to be here with you today. I'm going to paint a familiar picture for you. You run maybe hundreds or thousands of tests, and a handful of them fail. Whether this is locally or in your CI pipeline, you now have to figure out which tests failed, why they failed, and how to fix them. You open up the CI logs, you start scrolling through the pages and pages of test results, trying to find the failures among the noise. What you really want to do, though, is focus on just the failing tests, ideally locally, ideally in Visual Studio, where you can just debug them and get to work. So I'm Benjamin Michaelis. I'm a software engineer at Iterative. I'm the co-author of Essential C#, which is also a free learning resource going through Essential C#, beginning to expert, wherever you need to be, just hop in. And that's available at essentialcsharp.com. And I also built this small tool that I call the TRX to VS playlist. It's a .NET tool that improved how my team handles failed tests. So now when our CI pipelines fail, instead of sifting through the thousands and thousands and thousands of test results, we now automatically convert those results into a Visual Studio playlist that then lets us just download it and focus on just the tests that are failing locally in minutes. And this all started just as a little weekend experiment and has now turned into something that actually saves us time every week. So today I want to show us the journey of building this developer tool. We'll explore how this thing actually works, how you can actually use this tool to take a CI test failure and turn it into something you can actually debug in Visual Studio immediately. This is the actual workflow from something failed to let's actually debug here. Secondly, I want to talk about what I think is really the most interesting part, which is how I actually figured out how to build this tool. I'd never worked with playlist files before. I had no idea what the XML format looked like. But with GitHub Copilot helping me navigate the way and walk around some decompiled code, I went from nothing to a working tool that could solve my problems in not much more than a weekend. So we'll walk through some actual moments where AI helped me out, some of the lessons I learned along the way. And more importantly, the last thing I kind of want to cover is what this all represents. This idea that we can just take annoying parts of our workflow and just fix them. We can build a small tool that makes our lives better, and how AI is making that actually more easily accessible to more of us. By the end, hopefully you'll see the code, see this tool, see how it was built, and hopefully you'll walk away thinking I could actually build something just like this for my own pain points. So if all of that sounds good, let's dive in. The beginning of this journey starts with the Visual Studio playlist. If you haven't seen these before, they're pretty cool. Normally, if you haven't added any traits or done any tweaking, you view all of your tests in your test explorer and it looks maybe something like this. It's kind of just a wall of tests. However, if I want to just focus on a subset of those tests, I can use a playlist file to group together related features or ideas into logical subsets based on categories, anything you want. And because it has this grouping ability, we can use this ourselves. In case you haven't experienced what this playlist file looks like before, I'm just going to show you how to make one quickly. So here I have the Essential C# samples. So this is actually a tool that we use for our Essential C# repo. And I'm going to open up one of the chapters and we can select a specific test. We can select a namespace. We can select a different project. And I'm going to right click, select add to playlist here. That is visible. And I'm going to select new playlist. This has brought me out into this little playlist window where I now have a subset of all the tests. So instead of viewing all, what did I have? 1,300 tests, and we actually have multiple target frameworks. So we're targeting .NET 8, .NET 9, .NET 10 simultaneously to make sure everything works. I can focus on just a subset of these tests. This file I can actually go and save. So I could commit this into my repo if my team wanted to use this repeatedly, or I just want to save on my desktop because I'm going to come back to this over the next couple of days as I'm building something out. But now that we know that we can save a playlist file, and I can also reopen that back up to get to this exact same view, that means that this playlist file, which is an XML format, actually stores the data I need to be able to create a grouping in a subset of our tests. So this is the first part of the problem of how are we actually going to solve this. So instead of manually creating this file, we want to generate it automatically. But how do we do this? The next piece of this all is a TRX file. This is Visual Studio's test result format. They're very common, whether you knew that you've interacted them or not, but they're very common because they're the output from test runners and is commonly used with a lot of tooling that integrates with your test results. So every time that you run .NET test and specify a logger of TRX, you're going to get one of these. It's another XML format document that contains everything about your test run. Which test failed, which test passed, error messages, stack traces, timing info, anything you could possibly imagine. Let's open one of these up in Visual Studio just to kind of get a glimpse. So I have selected one off of my desktop, and it actually opens up in Visual Studio. And this gives us a nice look, instead of having to look at XML, of what is contained in that TRX file. It shows me which test passed, which test fails, even error messages, stack traces, a slew of abundance of information, when I ran the test, how long it took. The key part, though, is that it knows which test passed and which test failed. That's the piece that we want to use for our solution. When we focus on this and we take together the TRX format that we now have that can determine which test failed in our run, and we're now able to generate a playlist file, we could now theoretically put these pieces together. So how does this actually fit together in practice? This is what our workflow kind of looks like. We start with a CI pipeline wherever you run your automated tests. Some tests are going to fail in your pipeline, and the pipeline generates the TRX file automatically. This is something that .NET already does. Our tool then will convert the TRX file to a Visual Studio playlist, filtering just on those failures. We don't really care about all the tests. We just want to focus on the failures. The playlist then gets uploaded as a build artifact. So all we functionally have to do is see, oh, the CI pipeline failed, download the build artifact, open up in Visual Studio, and boom, we're actively debugging just the subset of failed tests that we're interested in. Let me show you what this actually looks like in a real pipeline. So I'm going to go open up the Essential C# repo, and I have a workflow file here. This is GitHub Actions, but this would be the same concept if you're in Azure DevOps or Jenkins, whatever you're using, the same concepts apply. When I scroll down here, you'll notice that I do some setup for the .NET environment. Hidden in here is where I'm going to do like my .NET build, my restore. And then I do this .NET test. The key parts of this is I run my .NET test, standard. I specify my logger as a TRX. And then, just out of view, I specify my results directory, just so I know where to expect this TRX file to show up, so it's not out lost in the ether and I'm hunting for it. I then have loaded this all into a GitHub action. So this GitHub action, all it's doing is wrapping that .NET global tool that we've built just to have a nice facade on the top, a nice layer to interact with in GitHub. But all it needs is a TRX file path. Where do I actually go find those TRX files? The test results from our testing. And I'm only going to run this in the failure case just because why do that extra work of filtering through to the failure tests, even though it only takes about 10 seconds on my pipeline when I don't need to. So let's actually do this. So here's an actual failed test run I have. I could start scrolling. This is maybe the normal flow. I could start scrolling through this, looking for the test failures. Oh, I see I have a test failure here. I can try to go find the name. Where's the name of my test? Somewhere the name of my test. Keep searching, keep searching. All in all, this is taking me time, and this is being difficult. Here we go. Here's a failed one. Equals given same reference. So I could copy this identifier. I could go find it in my Test Explorer window, and then I could fix that test. But there's more failures here. In this case, coincidentally, because I caused the failures, there's about 30 failures. So what can I do to improve this? So using this tool, I can now click on Summary. I can scroll down to the bottom, and we automatically produced a build artifact called testResults.playlist. I can now download this to my machine, as I have already done, and I will now open this up. Let's close the fake playlist that we made already. And let's just snap our window back into place here. We can click on this little button here in our Test Explorer called Open Playlist File. We can select the file. In this case, we called it merge.playlist. And instead of now looking at all 1,300 of our test we are now focused only on the tests that were actually failing. So let's run these all, and let's make sure that we actually are able to reproduce our failures that were on the CI pipeline and reproduce those locally. They're running. Great. Now this is maybe one of the coolest parts. This just came out in Visual Studio 2026, which just released a couple days ago now. This is maybe my favorite feature in Visual Studio that has come out recently. If you right-click on your failed test here, you can select this Debug with Copilot button. When I click this button, it's going to open up a, let's just snap this here so we can take a look at the Copilot window. Copilot is actually starting to go look at the test and is acting in agent mode where it has context of the full workflow, of all my code context, of everything in my project. But now because it's in this debug mode, not just simply the agent mode, it is actually able to go set breakpoints, and it's able to view values, do all the things that we would do, and it's able to do that on my behalf now. In this case, we have an event firing, and it looks like there's an exception, and so it thinks the property name is wrong. If we go look at the property name ourselves and try to get ahead, see if we can figure out what the problem is. Oh, there we go. It said it. So in our code, we referenced it as name1, the property itself. So here's the property. It's called name. We referenced it as name1. Oopsies. That's a bug. GitHub Copilot has gone and renamed it properly to be name of name. And it will continue on. Has it fixed it? It'll run it again. See it launching. And it has actually rerun my test after it fixed it. So now we have a passing test. So that's the whole tool in action. Pretty straightforward. But we just went from CI failures to actively debugging, and in fact, GitHub Copilot debugging and solving our problems in what, less than 2 minutes? Obviously, your mileage may vary, as this bug was a little bit maybe more simple. Yours may be a little more complex. But the point is that we went from a wall of noise to focused debugging in under a minute. So that's the tool in action. Pretty straightforward. Parse some XML, generate some XML, all the things. This, I think, is what makes it interesting, though, is the point I maybe mentioned at the beginning, that I had no idea how a playlist file worked at the beginning. I'd never parsed a TRX file. I'd never parsed a playlist file. So how did I figure all this out? We started, in my case, with the Visual Studio playlist file, like we looked at. And I wanted to know not just what could Visual Studio make at this moment in time. I can see obviously an example of a playlist file, but what does the actual schema look like? There's no public documentation to understand the Visual Studio playlist format. So I decompiled some assembly to see how the files actually worked. If we open up this window, here's a normal VS Code instance, as you might expect. And I can ask GitHub Copilot, tell me about the decompiled code you see. And it says, I have no idea. There doesn't seem to be any decompiled code. So it only has context of what is actually in my workspace. What I'm actually doing now is, instead of just doing what's in my workspace, I'm using the extension for ILSpy. So here's the ILSpy extension. And ILSpy is a tool on its own, but I'm going to utilize here, that allows me to investigate decompiled code or compiled code and decompile the IL. It gives me a guess as to what the actual C# code may look like. Now I use a little hack here. When I ask GitHub Copilot and I say, hey, can you help me figure out what is going on here? Because I don't actually have the decompiled code ready, I can double click on the files in my ILSpy extension. I can view the decompiled code here, but I want to give it to AI to help me with the context. So I'm able to go select one of these files. Let me just clear these out. And I'm able to select the Boolean rule kind file, and I'm able to add the file into GitHub Copilot's context, even though this file is located elsewhere on my system. Now that it is loaded into the context of GitHub Copilot, I can now ask it questions like, can you help me understand what the schema looks like? And after I see the schema, I can further prompt it, can you tell me everything about the specific attribute of it? And it'll give me all those things. The really sweet part is I didn't really know what I was doing all along. And AI was able to help me understand the core parts of a TRX file. AI amplifies your understanding. AI amplifies whatever you're trying to bring to it. If you know what you're trying to figure out, AI can help you navigate unfamiliar code. But if you're just guessing, I think AI can sometimes amplify confusion. And so we can use AI to actually help us understand the core principles. Instead of me blindly going and trying to create this tool, not understanding the intricacies of a playlist file, I may have been lost and my tool would have been a bust, but it actually works. And AI helped me with that understanding and helped me iterate on that process faster than I could have by myself. The next piece to this is a common practice that we have done in development for a long time. Test-driven development. Why does this sound familiar? It's because this principle existed before AI. Test-driven development is not new. We write a test, we make it pass, we repeat. What does this look like in the age of AI building this tool? Well, I gave GitHub Copilot some actual code, some actual examples of a playlist file that I had. So if we go open up our tool, this is the actual code. Let's close down the test results file that we had before. Here is a playlist file that I actually found on GitHub, so I had a real example. And I would go ask GitHub Copilot, hey, could you go make me a test, let's say that make sure that we can parse the rules of match not. And it would go actually write that test for me. You go input it, write the test for me. But I found there was a strategy that worked really well for me. Giving GitHub Copilot actual playlist files for my build, not abstract just descriptions, really helped it actually produce real and accurate results. I iterated in small chunks. Each test covered just maybe one parsing scenario or one result type, one edge case. And because I kept that context narrow, it wasn't like I was dumping my entire code base into the chat and saying, figure this out, build my whole tool. I kept it isolating. Can you help me parse this XML structure? Can you extract these fields? Because I was also operating off of real data, I was also able to catch when AI was making mistakes faster. When Copilot generated code that misunderstood the XML schema, the test immediately failed. So I think through this all, the tighter that we can make our feedback loops, the faster we can understand and catch when AI may be actually misunderstanding the problem. Next thing is just keeping it simple. I fall into this all the time, and maybe you relate to this as well, where I overcomplicate things. I want to make the most extravagant engineering tool I can, and it is maybe overkill for what is at hand. When I first open up a playlist file, it looks something like this. This is like exactly out of the file that we saved from what I showed you earlier about how to make a playlist file manually in Visual Studio. If I save one of those, this is what it looks like. There's a lot going on here. But I noticed something key about this. There's a version 2 indicator here. Makes me wonder, is there a version 1? How can I figure that out though? I could either start installing old versions of Visual Studio, hoping that I stumble upon a version that still generates the version 1 format, or I can use everyone's favorite tool, and I can use GitHub. So in GitHub, I can actually go use a search syntax that I have here. And this is advanced search syntax to allow me to search for a path extension, the extension of a file. So I want a file ending in .playlist as Visual Studio produces. And so I don't grab version 2 files. Let's see if version 1 exists. Just the way that it said version 2 on the version 2 one, just going to make a blind guess that version 1 might be a good guess. Upon searching, I can find that these actually exist. Here's one from the Power Platform team. When I look a little closer at this, this looks simpler. If we can see what's actually happening here, it's an add block that has just the test name, the fully qualified identifier. In my mind, that is a whole lot simpler than what is going on here. Maybe not as powerful, but simpler, way simpler. So I downloaded it, loaded up into Visual Studio, and it turns out it handles it just fine. The trap that I almost fell into there is I almost went and built the complex version 2 format first because that's what Visual Studio generates now. What I actually ended up doing was starting with version 1 because it was just simpler. It met my needs, and I could later add version 2 support once the core of the tool is working. So figuring out the simplest piece first, I built that, and then I only added complexity once I needed it. Once again, none of these ideas are revolutionary, but I think even in the age of AI, these core principles still stand true, they still are applicable, and they still are valuable. The last piece, kind of dovetailing off of that last make it simple practice, is working code first, perfect code second. Standard engineering practice, but worth emphasizing with AI. I got the tool working first, ugly code, quick and dirty, then I refactored. Why does this matter with AI though? If you ask AI to make it perfect while building, I find I do the same thing, but it does it as well, where it gets caught in the complexity spiral where it's happily generating elaborate patterns I maybe don't need yet. There's a saying, I think back in the Unix, old Unix blogs or something like that, that I've read before that says, make it right, make it work, make it right, and then make it fast. And it turns out that AI can help you through all these 3 of these steps. Making it work, the basic parsing of the V1 playlist format, AI helped me go fast here. It helped me write tests quickly, helped me understand the schema, the full scope of the schema, not just what I could observe with my eyes from the decompiled code. From there, it could help me make it right. It helped me understand and refactor once I understand the shape and the architecture I'm looking for, whether this will meet the design and guidelines I want. And only then, I didn't even have to make it fast in my case. This tool doesn't really need to go that fast yet, but AI could help me optimize with the context of real usage. There's actually tools now built into Visual Studio with the performance, GitHub Copilot and similar. I think those are the profiler. Those are really cool. But working code first, elegant code went second, and AI accelerated both phases. I just found that it's best to do them separately. Let's take a step back though. What did we actually just do here? We took a real pain point, scrolling through CI logs, hunting for failures, and we fixed them in a weekend with tools that are freely available to all of us. And here's what I want you to notice about that journey. The problem wasn't how do I rewrite our entire test infrastructure, it was how do I stop wasting 20 minutes every time CI failed. The solution wasn't building some massive enterprise system, it was simply parsing an XML file and generating another XML file. The accelerator in this all wasn't knowing everything about a playlist format beforehand, it was using AI to navigate the unknown parts quickly. And I think this represents something much bigger than just test playlists. There's been this shift happening, and maybe you've noticed it too in the past couple of years, where building small tools to fix our daily annoyances has gone from this big project I have to take on to sometimes it can just be a weekend experiment. Not because the problems have gotten easier, but because AI lets us navigate the unknown parts faster. So here's what I want you to walk away thinking. What's your annoying thing? Not what system needs rewriting, what small daily friction could you smooth out? The thing where you think, ugh, I just wish this could work differently, and then just keep doing it the old way because there's nothing to fix your problem yet. What if you spent your next Saturday afternoon building a fix for that thing? This tool is just a small tool that I built in a weekend that actually on Essential C# we use all the time. It is built into our pipelines. We use it all the time. Love it. I love it. I love it. I love it. And I use it all the time. And if you go build a tool on a weekend, you might get it working, you might not, but you'll leave with something. You'll have learned something, and the next Saturday after, it'll get even easier. So feel free to go try this tool, go clone it, break it, make it yours. Because I think that's the real lesson here. We can fix our workflows now. We no longer have to wait for someone else to build us the perfect tool. And AI doesn't completely write the code for us yet, but it is making me be able to ask the question like, I wonder if I could build that a little bit more often. I'm thinking that question a little bit more. Can I build that thing than I may be used to, because AI, it helps me speed that up, iterate on that process. So with that all, here's a link to all my links. There are some blog posts walking through a bit more of the nuances of this specific tool. And I would love to hear your feedback, whether on the talk or the tool itself. There's a link in there for that as well. Everything I showed you is on GitHub in that link, and I'm excited to see what else gets built.